Today we're looking at how we can combine functions, and really it's just like we would be combining regular numbers. All we're going to do is I want a combination of f plus g of x. That means I'm just adding the functions f and g, just adding them up. Same with subtraction, multiplication, division, it all works the exact same. The only issue with division, remember I can't divide by 0, so I have to kind of change my domain for this new function where my denominator, g of x here, does not equal 0. So let's see if we can create these combinations of functions. All we want to do here is to plug in f and g of x. So for this one, they want us to add. So all we're going to do is add these two. So f of x is 2x plus 1. G of x is x squared plus 2x minus 1. All I'm going to do is combine like terms. I have an x squared, I have a 4x. My negative 1 and positive 1 cancel out. So that's my new combination. All right, for g of x, g minus f of x. So I'll start with g of x, and then I want to subtract f of x. But here's the kicker. I can't just subtract it like this. I need to subtract all of it, because I need to distribute this negative here. So that looks like x squared. I have a 2x, and I minus a 2x, so that goes away. A negative 1 minus another negative 1. Minus another 1 is x squared minus 2. F times g is the most cumbersome. 2x plus 1 times x squared plus 2x minus 1. If I want to look at this one, I'm going to have to do some FOILing here. So I'm going to have 2x cubed plus 4x squared when I do the next one, 4x squared minus a 1. No, I'm sorry, that should be minus a 2x when I do my first times the last. Then for the inside ones, I'll have another x squared, so I'll put that down here, x squared. I'll also have a plus 2x, and I'll also have a, now my minus 1. And then I'll add these together, 2x cubed plus 5x, and that goes away, so just minus 1 for the last part there. Alright, and the last one, f of x divided by g of x. F of x is on top, g of x is on the bottom, x squared plus 2x minus 1. There's really not much I can do to simplify. I can look to see if I can factor and maybe something would cancel out, but in this case nothing does, so I'm done just right there. Now the other thing I can do is if I wanted to do like say f times g and I want that evaluated at, let's say 1. Well, I could go and do all this and simplify it and find my answer, but I should have 2 times 1 cubed, so 2 times 1 cubed plus 5 times 1 minus 1. So I would have 2 plus 5 is 7 minus 1 is 6. I can do that. But that's a lot of work. It also would be f times g of 1 we said is the same as f of 1 times g of 1. So I can look at each of those individually. Well, f of 1, if I plugged in 1 here, I would have 2 times 1 is 2 plus 1 is 3. So f of 1 is 3, and g of 1. 1 squared is 1 plus 2 times 1, so plus 2 is 3, minus 1 is 2. So that's 3 times 2, which equals 6. So either way, I get the same answer, but usually it's a lot easier to plug into your original functions rather than to get a whole brand new combination function.